Problem 32 asks us to graph the quadratic functions. You may have heard the graph of a quadratic function has a special name. It's called a parabola. It's a U-shaped graph, and because it's U-shaped, it changes directions. And that point where the direction changes, which is either the lowest point or the highest point on the graph, is called the vertex. So when we're creating the graph of a quadratic function, starting with the vertex can be really helpful. Well, it turns out that if the quadratic function is given to us in standard form, y equals ax squared plus bx plus c, then the vertex of that parabola has the x-coordinate of negative b divided by 2a. So for part A, my a value is equal to 1, my b value is 10, and my c value is 22. So to find the vertex, I just need a and b. The vertex for part A is going to be negative 10 divided by 2 times 1, so negative 5. So that's my x-coordinate of the vertex. So when I build my graph, what I can do in general, a good strategy for graphing, is to create a table of values, plug in some x values and find the y values. Because I know the vertex has an x-coordinate of negative 5, I want to make sure I plug in that value. If I do, I get negative 5 squared, which is positive 25, but then minus 50, 10 times negative 5, and plus 22, so we end up with negative 3 as our corresponding y value. So negative 5, negative 3 is our vertex. To find a few other nice points on our graph, let me go a little bit to the right and a little bit to the left from that vertex. So if I go to negative 4 and plug in that, and then maybe negative 6, I could also plug in negative 3 and negative 7 as other x values to try to plot on my graph. So plugging in negative 4 gives me positive 16 minus 40 plus 22, which equals negative 2. When x equals negative 6, I get positive 36 minus 60 plus 22, which is also equal to negative 2. When x equals 3, we get positive 9 minus 30 plus 22, which equals positive 1. And at negative 7, the y value is 49 minus 70 plus 22, which also equals positive 1. So what we're seeing here in these points is actually an important characteristic of our graph. There's symmetry across that vertex, specifically across the vertical line that passes through the vertex. The graph is symmetric on either side of that line. But the actual graph of the parabola doesn't include that line of symmetry. The graph of the parabola passes through these 5 points and others, but through the 5 points that I've plotted in this U-shaped way, again, where the vertex is, in this case, the lowest point on our graph. So we can approach part B in a similar way. Let's start by identifying the vertex. For the quadratic function in part B, the a value is negative 2, the coefficient of the squared term, but you'll notice there is no linear term, there is no x term, so the b value is equal to 0, and c is equal to 5. So when I'm looking for the vertex, I end up with an x-coordinate of my vertex of negative 0 over 2 times negative 2, but 0 above any number is just equal to 0. So creating a table of points for this graph, I want to center my graph around 0 because that's where the vertex is. Of course, if I plug in 0, I just get a y coordinate of 5. And then to test out some other values, I can plug in 1 and -1, 2 and -2. If I plug in 1, 1 squared times -2 is -2, plus 5 is 3. -1 is going to give me the same result because -1 squared becomes +1. If I plug in 2, I get -8 plus 5, which is -3. And the same thing happens if I plug in -2, because the negative becomes squared. So I get a +4 times -2 plus 5, which is -3. So I can plot these points on my graph. 0, 5 is my vertex. 1, 3, -1, 3, and then 2, -3, and -2, -3 are 5 nice points on my parabola. Again, we see this symmetry around the vertical line through the vertex. And sketching a curve through those points gives me my graph. So we graphed a couple of quadratic functions using this vertex formula for the x-coordinate of the vertex, and then plugging in a few values near to that point to create a table of points that we could plot on the graph and draw our U-shaped parabola through those points. This is not the only way to graph quadratic functions. There are other techniques that can be applied. But this idea of creating a table of values of x and y coordinates, plotting those points, and then sketching the curve through them is a good general approach to graphing functions, especially if you have a sense of what the general shape of the graph should look like.